Hi, I'm Mohit Chaudhary. I'm a PhD student at Marseille University. I work in the Department of Theory and Numerical Simulations at CNUM, which is lab in Marseille. My thesis work focuses on numerical techniques to define or to model surface plasmon resonances in gold and silver metal clusters. And it is important because theory is generally used for its predictive power. But until and unless we don't know what are the ways we can accurately reproduce the results which are already present, we cannot really use the full potential of the predictive power of the theory. And that's like the main motivation and behind the work that I do. In my analysis, I use computational tools, numerical techniques, and it's called density functional theory and time-dependent density functional theory. So density functional theory is a simpler way how we can find the ground state of the system, that is the electronic ground state of the system, without taking into account various complicated interactions of electrons at an individual scale. We work with just the total charge density. And time-dependent density functional theory is nothing but a way to calculate absorption spectra from the ground state. So the key results from my thesis so far has been that I have been able to reproduce spectra of silver nanoclusters with just 4 atoms, that's almost molecular-like, all the way to a cluster with about 1,000 atoms. So with just one method, which is DFT plus U, I was able to reproduce all the results. One thing that I really appreciate about my research project is that the technique that I use has been there in the literature for quite some time, but never been used to calculate the spectra. And people have been using more complicated techniques to get the same spectra that I've been able to get using a very inexpensive technique called DFT plus U and TDDFT plus U. On top of that, I was being able to reproduce size-dependent blue shift as we go from bigger particles to smaller particles in silver metal clusters. And at the same time, for the intermediate clusters, there is something called oscillation in the SPR peak because of the shell closing effect of superatomic states, and I have been able to reproduce that as well, and it's a big achievement in itself. The only advice for the other researchers, especially the PhD students, will be to be patient, because research is a slow process. You will experience a lot of lows and a lot of ups at the same time, and patience is the key. Result takes time. Thank you.